Good afternoon. I'm Hugh Dyer, a director in RSK's Geosciences business. Welcome to the May edition of our 2025 series of Down to Earth webinars. These cover a broad range of subjects and are available afterwards on our YouTube channel alongside our previous talks. Our talk today will be given by Helen McMillan from our Contaminated Land Assessment team within the Geosciences business. Helen will give us an overview of the conceptual site model process and the importance of identifying uncertainties. But first, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted throughout the webinar. During the presentation, you can post questions online and there'll be a Q&A session at the end of the presentation. We'll answer as many questions as possible at the end of the talk. Those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you'll receive a link to a short survey. If you could please take a few minutes to provide feedback so we can improve on our future webinars. Now, please let me introduce our speakers today. Helen is the director with RSK Geosciences and a chartered geologist and associate member of SOBRA, with over 20 years experience working in environmental consultancy. Helen is a hydrogeologist specialising in contaminated land management, has worked across a number of sectors, including petrochemical, energy, construction, waste and infrastructure. Helen is technical lead within RSK Geosciences for quantitative risk assessment and leads geosciences teams across all areas of land contamination risk assessment. I'll hand over now to Helen to guide us through the conceptual site model process and understanding the uncertainties which can impact upon the development and refinement of the conceptual site model.
Okay. Thank you, Hugh, for the introduction. Oh, thank you. And it's great to see so many of you here joining this. I hope you find the webinar useful. So I'm just going to turn off my camera while I go through my slides. So as you were saying, my presentation today, there we go, is on identifying and refining uncertainties in the conceptual site model, or CSM as it's sometimes abbreviated to. So the CSM forms a foundation of the land contamination risk management process that underpins the geoenvironmental risk assessments we undertake. It's a live document and it needs to be reviewed and updated as more information becomes available about a site. And that's to help us make informed decisions and identify the best way forward in relation to managing risks from land contamination at a site. However, it's really important to develop an understanding of any assumptions that underpin the conceptual site model and their associated uncertainty, which I'm hopefully going to illustrate over the course of this presentation. So just in terms of what I'm going to talk about, I am initially going to provide a bit of an overview and an outline of some basic concepts about developing a CSM and how you can identify potential uncertainties and the measures you can take to reduce them. I'll then go through a couple of case studies which illustrate the importance of identifying and undertaking further investigation and assessment of uncertainties. So let's start. What is a CSM? So the Environment Agency Land Contamination Risk Management Guidance defines a CSM as a representation of the characteristics of the site. It shows the possible relationships between contaminants or sources, pathways and receptors. It will form the basis of your initial assessment and all future decisions as you progress through LCRM. So a source, that's defined as a contaminant or pollutant that is in, on or under the land and has the potential to cause harm or pollution. So this could be a primary source, such as a tank containing chemicals or fuel, or it could be a secondary source, such as soil or groundwater that has been impacted by contamination. A receptor is something that can be adversely affected by a contaminant. So this can include human health, controlled waters, such as groundwater and surface water. It can also cover ecological receptors and property. And a pathway is a route by which a receptor could realistically be affected by a contaminant. So you can have sources, pathways, and receptors existing independently of one another. However, it's only when all three are present and there's a plausible pathway linking a source to a receptor can a potentially complete contaminant linkage exist. So in the example you can see on screen, we've got a source comprising elevated metal concentrations in soil that's located in a residential garden. So site users could be exposed to the soil via direct contact or consuming vegetables grown in that garden. So that results in a potentially complete contaminant linkage that would require further consideration and investigation. However, if you had the same source, but say the site was covered in hard standing, there wouldn't be a pathway for users to become exposed to direct contact pathways, and certainly not from vegetable consumption. So in that case, that contaminant linkage would not exist. So I really like this definition that British Standard 21365 has about a CSM. It defines a CSM as a synthesis of all relevant information about a potentially contaminated site, with interpretation as necessary and recognition of uncertainties. It should be an iterative process of refinement in which the uncertainties are recognised and reduced as more information becomes available. Further investigation should be considered if the uncertainties are too great to permit realistic risk assessments to be carried out. So you really do need to consider the CSM as a live document that's continually refined and updated as a project progresses to reflect our increasing understanding about the site. So we always start a risk assessment by undertaking a Tier 1 preliminary risk assessment, and within that you develop an initial conceptual site model, and that identifies potential sources, pathways and receptors that might be relevant to your site. And from this you complete a qualitative risk evaluation to determine those contaminant linkages that are plausible and could present an unacceptable risk to the receptor. So at this stage of assessment, your CSM is likely to comprise a number of hypotheses or assumptions that you're making about the site. And as such, it's really critical to outline any key uncertainties, limitations and data gaps as part of this process. You can then undertake further investigation and assessment to help quantify those linkages as part of subsequent Tier 2 generic quantitative risk assessment, or even a Tier 3 detailed quantitative risk assessment to help reduce the uncertainty. But there needs to be a balance between the cost and time of obtaining additional data versus the overall benefit to the project. The amount of data that you need to collect to sufficiently characterise a site will depend on several factors, such as the objectives of the investigation, the complexity of your site, the sensitivity of the site, and the degree of risk that's considered to be acceptable, and the level of uncertainty you're willing to accept. In some cases, you might decide you've got sufficient information to characterise your site following the initial CSM. However, I'd say that's more the exception than the norm. For most sites, you're probably going to undertake some form of investigation, which might require one or more phases of site investigation to obtain the data you require. And so for each phase of investigation, you need to make sure you're refining that CSM and determine whether the information confirms your initial assumptions, or is there anything that makes you reevaluate your CSM, and do you need to add or remove contaminant linkages requiring further assessment. So just each process of refinement just hones your CSM into those contaminant linkages that are really of significance. So this slide is just showing how a CSM can be presented. It can be as a written description, a tabular matrix, you can use maps, you can use a simple illustration like that drawing in the top right, or you can, once you've got more site-specific data, you can draw more detailed cross-sections and add your pollutant linkages to that, as this drawing in the bottom right showing. Or most usually you use a combination of all of these. They show contaminant linkages and can be used to help evaluate the risk as part of the risk assessment process. And they can also illustrate any areas of uncertainty and gaps in information that might require further assessment to address them. So it's a requirement of LCRM that all uncertainties and limitations are recorded during the risk management process, and that possible consequences of these are considered in relation to the work that's being completed. So when you're going through this, you really need to have a critical thinking mindset where you're questioning, analysing, interpreting, evaluating the information available to allow you to make an informed decision about the site. So when you're going through a site assessment, you should keep these following criteria in mind. So is the data that you're collecting relevant to the contaminant linkage you're assessing? There's no point getting data that's not going to help you address that contaminant linkage in more detail. For example, if you've not got a vapor or volatile source, should you be spending a lot of money getting VOC samples from soils, for example? Do you have sufficient data to inform your risk assessment with the necessary degree of confidence? Is the information that you're collecting, is it reliable and reflecting the true or likely conditions at the site? It's also really important that the information you collect is transparent and that the decision-making process is clear. Ultimately, you need to decide, have you got robust information to enable you to make an informed decision about the site? So what you really need to ask yourself is whether the level of uncertainty identified is acceptable, or do you need to undertake further investigation and/or assessment to address that uncertainty? Okay, so talked about uncertainty importance to include it, so I thought it'd be useful to outline some examples of uncertainty that you might come across. When you start an assessment at the desk study Tier 1 preliminary risk assessment stage, you're probably going to have much more uncertainty at this stage of the process. A lot of the information that you get comes from desk-based research, including historical, geological and environmental maps. Common uncertainties at this stage could include uncertainty on the presence and extent of any contamination, the type of contaminants that might be present. You may have uncertainty surrounding your ground conditions, such as the nature and thickness of strata, whether you've got any May ground presence, the depth to bedrock, if that's something that you need to look at. You might also have uncertainty in relation to groundwater conditions, including its presence, if it's present, what the depth is, the groundwater flow direction, and you might also have more than one aquifer that you need to consider. Development plans. So I've included this because a lot of the time they may not be available or they might not have been finalised when we undertake our risk assessments. So you could have uncertainty about cut and fill requirements, drainage being put into the site, and the location and nature of the buildings that are being put in, whether there's any areas of hard standing, and also more sensitive areas like soft landscaping and garden areas where these are going to be. Could climate change and extreme weather affect your site? That's another uncertainty to look at. When you get into doing site investigations, you may have some additional uncertainties that you need to address. Do your analytical results confirm the site observations? Is there anything that you're getting that's unexpected? Have you got adequate site coverage? Were there any areas that couldn't be assessed? Also, when you're doing your generic quantitative risk assessment, the generic assessment criteria that underpin those are developed usually by models, and they have assumptions relating to land use, exposure pathways and receptors. Are they representative or sufficiently precautionary for the site that you're looking at? So to address uncertainty, you're going to need to make some reasoned assumptions, and it's therefore really important to make this as clear as possible as part of your decision-making process and justify your choices. because as you can imagine, some of this can be a little bit subjective. So I've spoken about identifying uncertainties. So how can you go about reducing them? So you can aim to reduce your uncertainties that you've identified by the following things. You could undertake some further desk-based research. Is there additional data that you could request to view that isn't maybe in the public domain? You can also consider non-intrusive investigations. Do a site reconnaissance. I mean, that's really essential as part of any Tier 1 preliminary risk assessment. But there are other options. Could you look at using geophysics? That can be invaluable in helping identify buried structures. It can also sometimes be used to map out contaminant plumes. So it can really help you understand where some key risk areas may be to help focus any further investigation. Also satellite imagery, and that sort of technique, it's becoming much more available. So can you look at satellite images to help with your site characterization? You can also do intrusive investigations, so going in, taking samples from the ground using drill rig, trial pitting, and other methods. So usually you would maybe need to have a think about doing a phased approach to this. You might want to start doing an initial exploratory investigation just to get your eye into the site. Is it confirming your CSM? There may be a requirement to do some more detailed investigation later on, just to really find where your contaminant sources are and to confirm ground conditions. And you also might need to do a supplementary site investigation to help you delineate your sources in more detail, particularly if you're wanting to go towards remediation. So you want to make sure you're honing in on those areas as precisely as you can. Monitoring and sampling of groundwater, surface water, ground gas is also something that you can do, and you can do it over a range of conditions. So you can capture seasonality or low atmospheric pressure drops, etc., to help inform your risk assessment, to make sure you've got a range of conditions that might be present at the site. Having adequate QA, quality assurance and quality control procedures in place can also help reduce uncertainty. And then when you're looking at the data you're collecting from your investigations, you can look at multiple lines of evidence to help inform your decision. And that can also include statistical analysis and trend analysis. You can also undertake a detailed quantitative risk assessment to develop site-specific assessment criteria. And if you're doing that, you should always complete a model calibration and sensitivity analysis. And that would just allow you to provide greater confidence in the results that your model is providing you. So I've added this slide in because there's a National Quality Mark scheme, which I'm sure a number of you are aware of. This was introduced in 2017 to help ensure submissions under the planning regime for land contamination management work were able to meet the necessary technical and regulatory standards. It's a voluntary scheme. It also includes a means to become a suitably qualified person or an SQP, and it's also got links to the Society of Brownfield Risk Assessors, or SOBRA, accreditation scheme for risk assessors. One of the key parts of NQMS is to identify limitations and uncertainties as part of the reporting process and consider the possible consequences of them. It also highlights that this process can be subjective, and as such, a suitably competent and experienced risk assessor should be included in this process. So this is a scheme that RSK endorse and support, and we currently have 12 SQPs and 6 accredited risk assessors under SOBRA, which I think is amongst the highest of any consultancy in the UK. It doesn't cost much to put a report through NQMS. It costs £75 plus VAT for a report to be registered. And and that confirms it's being checked for quality by an SQP. So reports with an NQMS declaration can provide additional confidence to regulators that the report's been completed in accordance with legislation, guidance and best practice. And it also shows them that uncertainties have been identified and addressed and recommendations made where possible to reduce them. Okay, so it's probably something that you might want to consider if you've got maybe, say, a particularly complex site, or you're wanting to get it through the regulatory process maybe a little bit more quickly. It sort of provides that confidence to authorities that it's gone through a very good sort of technical review and audit. Okay, so I'm now going to go on to some case studies, and these both went through NQMS, so they've been validated by that process. So these case studies are going to illustrate the importance of identifying uncertainties and exploring assumptions made in the conceptual site model, and how more detailed investigation can sometimes lead to a different insight emerging. Okay, so the first case study I'm going to look at comprises a historical sawmill and timber works, and it'll locally be known as the creosote site. So immediately alarm bells ring that you think there's going to be contamination there. Creosote's a dense non-aqueous phase liquid, so that means it sinks rather than floats on top of groundwater, and it continues sinking until it reaches a low permeability layer, and then it will accumulate on top of that and migrate with the topography of that layer. So we had the advantage of this site that some previous investigations have been completed, and this formulated the CSM you can see on the slide. From this, we knew that the geology comprised May ground of variable thickness and overlaid granular river terrace deposits, which were underlined by a stiff cohesive till, which we knew had been proven to 3 meters thick. The site was found to have been impacted by organic contaminants, and they comprised creosote-related contaminants such as hydrocarbons, pHs, phenol, and ammoniacal nitrogen. We identified potentially complete pollutant linkages to human health, groundwater, and surface water receptors. The evidence from the SI suggested that the till underlying the site was cohesive, and their study information suggested the till layer could be up to 10 meters thick. We didn't find evidence of impact in the till, and it was assumed that this could be presenting a protective layer that may be preventing migration to the bedrock aquifer. However, the site was less impacted than expected, and no NAPL source was identified. So a key data gap was at the base of the river terrace deposits hadn't been found, and as the base of the river terrace deposits hadn't been found, there's a potential that a DNAPL source had yet to be recovered. So key uncertainty was the key source areas weren't fully delineated. DNAPL was suspected but not confirmed. And there was also that assumption that the till could be acting as a barrier to vertical migration to bedrock. So to help resolve these data gaps and uncertainties, we completed a supplementary investigation on the 3 areas that you can see highlighted in yellow. They were our target areas. And the main focus was to delineate the hydrocarbon impacts that had been identified previously. And we wanted to further understand the soil source zone, underlying groundwater, plume, potential for free-phase product, and develop a better understanding of the deeper geology and confirm whether or not that till was acting as a barrier. So this is the CSM that we refined following the investigation, and it really allowed us to characterise the site in much more detail. So we had additional coverage, we looked at multiple lines of evidence to understand the contaminant linkages, and we just developed a much better understanding of the geology and the source areas. It showed the DNAPL was present within a localised area, which you can see by the red part here. It's DNAPL, with a dissolved phase plume, which is shown in the yellow, migrating from this, and it was kind of really located within a central site area. So we've managed to delineate our NAPL soil and groundwater sources. We identified DNAPL. We managed to show that the till was not acting as a barrier to vertical migration where DNAPL was identified. Previously, our investigation had just sort of characterised the shallow geology. We went much deeper, and in this area, I think because it's where a process happened, just the volume of creosote that had been used there had managed to work its way down into the deeper aquifer. So it wasn't acting as a barrier there. However, it was acting as a barrier where there was dissolved phase contamination. So in areas where it was just dissolved phase, there was no risk of it migrating to depth, just where we had the DNAPL. So this allowed us to identify key water source areas relating to the water environment linkages that would require remediation, as you can see on this slide. So it really honed in to something much smaller than it was previously. So this site won a Brownfield Award in 2022 for Best Project Preparatory Work, which is something that we're very proud of. So that was a great project to work on, and really shows the value of getting additional information to help confirm assumptions that you're making in that CSM. So going on to another case study, and this one relates to a former agricultural dealership undergoing redevelopment. The operational area of the dealership was located in the west of the site, and that included some historical diesel and petrol underground storage tanks that had been decommissioned. The eastern and southern areas, you can see from the imagery there, they appear to be largely undeveloped. So a correct assumption was made, or an assumption was made, which seems very informed, that the greatest risk of contamination would be in the area of the building and the underground storage tanks. And this was considered when development proposals were made for the site, and a lot of the new buildings were located in that undeveloped land, with the former building being relegated to a car park area. So, fair assumption, you think? However, when further investigation was undertaken, it was actually the undeveloped area that had the greatest contamination impacts. A measurable thickness of NAPL was identified in the eastern portion of the site, and that comprised petrol and diesel. And there was an area of suspected NAPL surrounding it. So you can see the measured NAPL in pink and suspected NAPL in yellow. So to investigate the source area further and help inform remediation operants, a supplementary investigation was completed to delineate the NAPL in more detail. And from this, we were able to constrain the NAPL sources to a much smaller area, as you can see by the red. There's also an area of suspected NAPL shown by the orange, and surrounding that a dissolved phase plume. Also, the site investigation identified some hydraulic hoses that were buried in the southern portion of the site. So I guess the moral of this story is that contamination may be in areas that you might not initially expect it to be. So it's just something to think about. Just because it shows something's undeveloped doesn't mean that contamination is not there. So ideally, before you start, I guess, getting your development plans together, maybe undertake some initial investigations just to help characterise and confirm that where possible. So this slide is just showing the same site but in cross-section form, and it had been anticipated that the three-phase product had arisen from the underground storage tanks, and it had migrated within a shallow granular till layer here, as you can see. However, it wasn't known if there was still ongoing entry of soil from soil sources, and there was an uncertainty about whether contamination was migrating to depth, and also whether there was off-site migration that could occur from the groundwater plume. So the additional investigation that we completed, we gathered more information, and then we'd find the conceptual site models you can see here. were able to prove there was no ongoing soil source, there was no vertical migration pathway to bedrock, and also there was no lateral migration off-site. The contamination was really constrained within these shallow granular till layers, and they were shown by the investigation to not be of any significant lateral extent, and that was providing the barrier to both lateral and vertical migration. So again, it just really helped focus in remediation options for that site, and was able to get regulatory sign-off for planning and for the development to commence. Okay, so I am just going to summarise quickly now what we've been going over, and hopefully I've been able to demonstrate the value of the conceptual site model. It's invaluable as a tool to aid in your decision-making process when you're managing contaminated land or land contamination. Recognising, identifying and exploring key uncertainties is crucial to this process. And I've also shown that it's kind of mandatory if you're following the relevant guidance, LCRM and British standards. It's a critical part of that. And ultimately, the keys to success is by having good site characterisation and conceptualisation. And I'm going to end with a quote by someone much more intelligent than myself, Einstein himself. And this is a quote I thought was quite nice. It says, "The important thing is not to stop questioning. Curiosity has its own reason for existing." And I think this is something we do as children. Anyone that's got young children in their life will probably be bombarded with questions of, but why, but why? And we seem to stop that a little bit as we get older, but having that critical mindset, thinking about things, exploring, problem solving, they all go hand in hand. And it's really something that we should be doing to ensure we're achieving the optimum result for our clients. So I'm going to leave on that note, and slide, that's my contact details. I am going to stop sharing my screen. I hope you've enjoyed the presentation.
I'll just come back in there. Thank you, Helen, for that presentation. Really very, very interesting. We do have a few questions coming in. There's still time to submit questions if you've got any questions for Helen. So first of all, how do you determine which uncertainties are worth investigating further?
Okay, thank you, Hugh, and thank you for the question. So how you determine which uncertainties you should consider further, I think it all goes back down to, it's all going to be site specific. It'll all go down to developing that initial conceptual site model and identifying those linkages that you're maybe needing to explore further. It is going to be site specific and subject to various things about how sensitive your site is, the level of uncertainty you're willing to accept. So, for example, it's quite easy from a tier 1 preliminary risk assessment perspective. You're going to have a lot of uncertainties there, and you most usually are going to sort of undertake a site investigation to look at that further in terms of determining your ground conditions, whether you've got potential for contamination, the type of contaminants that's there, and also, I guess, groundwater flow and direction. And then it's just going to be a case of reviewing and refining that in relation to your conceptual site model, and understanding the level of risk that you're willing to take from that. You're never going to be able to fully conceptualize you can conceptualize a site, but it's trying to get it, I guess, going from conceptual to what's in reality. So it's just sort of looking at those linkages you think actually, if an uncertainty could sort of really change your conclusions and recommendations that you're making, those are things that you should look at further. Like the first case study I had, there was that assumption the till was providing a barrier to the underlying bedrock aquifer, which was a receptor, but we didn't have the proof. So we went in and we investigated that further, and it actually showed that the till, where there was that DNAPL, where a lot of loading had happened, the till wasn't providing a barrier to contamination migration. So, but it was in other areas. So I think it's looking at that sort of level of risk, and looking at the site-specific nature of what you're going to.
No, that's brilliant. Thank you. And probably leading on from there, is there really any value in developing an initial CSM and preliminary risk assessment if we're likely to go in and do the site investigation anyway? I suppose as a risk versus would it change what we're going to do anyway?
Yeah, so that's saying if you're going to do a site investigation anyway, what's the point in doing a preliminary risk assessment? Well, I would say the preliminary risk assessment and developing that initial conceptual site model is vital. It forms the foundation of everything that we do. It's a requirement of LCRM. So if you're following best practice and guidance, you need to be doing that initial tier 1 risk assessment and initial conceptual site model development. And that really tells you, well, what contaminant linkages you've got that might be worth investigating further. And from that, you can tailor your site investigation design to suit. So if you don't know what you're looking for, how can you design an investigation around that to make sure you're getting the information you want? And it's invaluable because it allows you to, as I said, expose contaminant linkages that are a potential risk. It allows you to hone your data collection to that. For example, if you've determined that ground gas isn't a risk at your site at the preliminary conceptual model stage, you haven't got an obvious gas source, and what's the point in suggesting doing gas monitoring if that's not a complete linkage? Obviously, if you do an investigation and you start finding sources that might require further investigation, you can then add on to that linkage and recommend doing gas monitoring at that point. So that's just an example. So yeah, I would say you kind of need to know what you're investigating to design an adequate site investigation. So the tier 1 PRA is an essential part of that process.
Thank you, Helen. So probably the next question leads again on from there. How much detail would you put in your CSM, or how much detail is useful or required to support outline planning for a site?
Well, I guess that's going back to your tier 1 preliminary risk assessment, and looking at the available data sources that you've got. You want to be able to have enough information to initially characterize your site and understand what linkages might be present that you need to investigate further. So I guess it's that desk-based study, looking at all documents available, just to provide an indication of what might be there, how you might need to manage that risk.
Okay, so yeah, definitely based around the risk assessment and having a good idea of your site. The next question, sorry, I hope I'm not breaking up too much. The next question, would you recommend or would you suggest creating a 3D model for the CSM, which can then be refined compared with producing plans and cross-sections?
That's a good question. I think that all goes into how complex your site is. It maybe adds value to your more complex sites, maybe where you've got multiple aquifers, different sources, and how you'd present that. more simple sites or straightforward sites, I think, you know, having those maps, those plans, the cross sections are great. But developing a 3D model, obviously, it takes more information. They're quite data hungry. And I guess that has a cost implication associated with it. So it's again just balancing the cost and the timescales involved with the ultimate benefit it's going to provide your project. I'd say definitely in some cases it would be definitely good to explore, but it's, you know, it has to be done on a site specific basis. So yeah.
And again, the uncertainties in, you know, I know that we always put in our report that the interpretation is based on the information we have and conjectured between boreholes. Obviously, once you start producing a 3D model, you're having lots more areas of uncertainty where you're conjecturing between the boreholes.
Yeah, I mean, you can look at 3D in a way in terms of, you know, having those cross sections and plans and putting in plume plots, or, you know, plots showing, you know, made ground extent or superficial extent. So there are ways of looking at it in a more aerial basis. But yeah, it's just as you say, it's just have you got enough data to allow you to produce a 3D model? And it is always, you know, essential to look at those data gaps and uncertainties. And it's fine, we're never going to get full coverage of a site, but we just need to make sure we're making reasoned judgments, looking at the data we've got, not looking at things in isolation, looking at multiple lines of evidence, and that could include, you know, looking at both like ground conditions plus the source chemistry, etc. together. And it's really just allows you to make a reasoned or a reasonable judgment that you can justify and that can stand up to scrutiny if you're queried on it.
Fantastic. So the last question, I think, is probably one that we'll answer and we can reply direct to the person. But was just asking, within the case of the creosote DNAPL, what remediation was undertaken to deal with the contamination, which I think is within your case study. Whether you want to answer that now, whether you want to put that out as a follow-up to the presentation.
That one, so we did provide a remediation options appraisal for that site to look at various linkages and kind of develop some ballpark costs for undertaking the remediation. I guess with that site, the development plans haven't been fully finalised, and it's being thought about how best to manage that site going forward, but no active remediation has been completed on it, except for some off-site pathways that we've looked to address. But yeah, we used the information we collected to develop an outline remediation options appraisal, looked at potential remediation strategies that could happen, but without the development plan in place, it's quite difficult to move things further forward.
Okay, no, that's brilliant. Thank you, Helen. So I think we'll end the questions there, and any further questions will be answered once Helen's had a chance to review these. So thank you again to Helen for a fantastic presentation and also for detailed answers to the questions. Our next Down to Earth talk will be on Tuesday, the 10th of June. And we'll look at the reuse of soils in construction and the CLARE definition of waste code of practice. Please remember to complete the feedback following the presentation. And thank you for attending today, and we'll see you again in June.